and we have shown the results. Then we have image source classification depending on the differences in the geometry of the devices. Imaging sensor. We have a linear sensor in one case and we have a 2D sensor in another case. That allows us to discriminate between the two devices, scanned and non-scanned images. And we have shown the similar kind of how these intrinsic and extrinsic techniques can be used for printer identification and what kind of results we are going to get. I would like to save the next slide of future discussion, and before that I will ask some questions. Anyone has? Yeah.
The software you've written for this, is it portable across different cameras? I mean, if you apply the same algorithm to different, does it work?
Yeah, it will work provided we have to have the training set. If we are giving an image which is not coming from the one of the camera which is in our database, then we are not going to classify it correctly. Yeah.
Okay. Is the denoising algorithm well known, or did you guys write it?
No, it's one of the denoising algorithm which gives pretty good denoising performances, that is wavelet based, and it's not particular that we are destined to use that denoising algorithm only. If we have a better denoising filter which can support us giving the fixed pattern noise. So basically that question comes to...
Actually, right now we're using a wavelet-based denoising filter we wrote ourselves, based on some prior work which has been done on the forensic characterization. And we're currently working on some newer denoising techniques, which are current. So, does that answer your question?
Yeah.
Yeah.
Basically it will depend on how we model the noise. And different denoising filters will help us picking up different kinds of noises models. Any other question? So let me go ahead to the future work. What we describe certain models of the devices and how these models help us to classify different devices into different classes. And we described an algorithm for image source classification. But that algorithm essentially dealt with only two classes, scanned and non-scanned images. We wish to extend this work for three-class classification, where we can figure out whether it's a scanned image, a camera-generated image, or it's a computer-generated image. And then we used to use these techniques for authenticity detection. And there is one of the questions whether these techniques work when we have manipulations. That's another agenda we have, that test these techniques, how well they work, and what modifications can be done in them to make them work in case of we have manipulated images. And if those techniques work in those scenarios, then we will be interested in the finding type of manipulations done, and maybe the region of interest where the manipulation is done. Say a certain region of the image which has been copied from another image and pasted there, or a certain region of image which has been blurred or removed from that image, and things like that. So, any other questions? No questions?